So yesterday we went through and we talked about the formula and we talked about what the parts of the formula are, and then this is the formula in notation format, okay? What does X stand for?
Number of successes.
That is the number of successes. Very good. What does N stand for?
Number of combinations.
N is the number of trials. Okay, good, good. What does P stand for?
P stands for probability of success.
That's the probability of success. What is 1 minus P? That is your probability of failure. Very good. Now, if I take N, which is the number of trials, and I subtract X, which is number of successes, then what do I get? I get the number of failures. Okay, cool. So, does everybody feel like they understand that formula?
Yes.
Okay, cool. So, before we go on to the mean and standard deviation, I do want to show you guys in your calculator how you can do the number of combinations. Yes?
So, L minus P is probability of failure, right?
N minus X is the probability of fail. Oh, I'm sorry. 1 minus P is the probability of failure. Yes, sorry. Yes. Okay, so let's talk about N choose X. N choose X. Now, in your calculator, it doesn't use an X. It uses an R, but it's just a different letter, okay? So in your calculator, it's under NCR, which is found under math, probability, and number 3, and it says NCR. Now, for most of you, thank you, for most of you who have the yellow or fatter calculators, there's a little quirk about this. You have to put in the number of trials first, then go to math, probability, NCR, and then put in your number of successes, okay? So let me show you what I mean here. What I mean is, here is your calculator. So, for example, yesterday we had 4 and we had a number of successes of 0, right? So I would have to put in 4, then I would go to math, probability, number 3 for NCR, and then, so the 4 would be first, right? And then I would put in a 0, and I see here that I get a probability of 1, or a combination of 1. So that was with 4 trials and no successes. There was only one way for that to happen, right? When we did 4, math, PRB, number 3, 4 choose. Whoops. Ah!
Factorial.
Clear. Good golly.
We also did that.
Clear. 4, math. This is very sensitive today. Goodness. Good.
I think you're just kind of at it.
Jeez.
Again with the intelligence.
Choose 1. So when we had 4, choose 1, how many combinations was there? 4. And there it is. Okay? Yes.
My calculator's like not doing that.
Yeah, mine says error.
No, I'll show you. I'll guess.
It's like-
Look.
So you have to put the 4 in first.
And then they
Put a number
math
on
probability 3. And then
It is number 3 the NCR.
probability.
Okay, and then are you putting in the next number?
4 right there.
Or it's just so
And you're gonna go over and you're at 1
explicit.
success.
Oh, so here's what y'all's looks like. Actually, I'm sorry.
I got you, Miss Lee.
This is what y'all's looks like. Yours says like 4 and then it says NCR, and then you have to put the 1 right there. So yeah, so you have to put it in like that. You just have to type it in like that.
Oh, okay.
I'm sorry.
Not real.
Yeah, my bad. My bad.
Huh?
Okay, so that is how you can find out the number of combinations. So, for example,
1 being success.
let's say we have 20 things in a population, or 20 trials, sorry, we have 20 trials. And we want to know the probability that we get exactly 5 successes. 20, choose 5. 20, choose 5. Tell me how many different ways can we have 20 trials with 5 successes? 20, choose 5.
Oh,
Wow.
20. Choose 5. There is 15,504 different ways that we can have 5 successes in 20 trials if I don't care when the successes occur. Obviously, you guys don't want to write out that many combinations, right? No, you do not. Nor do you have time, nor do you want to. Okay, so this is how you can find out the number of combinations without having to write out fail, success, fail, 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 success, fail, fail. You don't have to do all that, okay? Everybody feel okay about this? No? Okay, well, don't really know what to tell you there, but okay, cool. Good times. All right. All right. Here's the good news. Here's the good news. A lot of times you won't need to know that number. Let me say that again. A lot of times you won't need to know that number because your calculator will actually calculate the full binomial answer for you.
Wow.
But you do need to be able to recognize this formula. And you need to be able to understand what goes into which place. That is an important part of the binomial distribution. You have to know how to recognize the formula, which the formula is on your formula chart, but you have to know what goes into which of the places. So you guys are always going to see me, when we do examples, you are going to see me write the formula with the numbers that go in the places, and then you'll see me use the calculator to get the answer, okay? So we'll go through that whenever we get to our examples today. All right, mean and standard deviation. Mean and standard deviation. Yes.
So, is the equation we're on the top essentially n's take r?
Yes. N take R. Yes. Yep. Very good. All right, mean and standard deviation. So, the mean and the standard deviation of a binomial distribution. Now, yesterday, at the very end of the last page, we made a probability distribution, right? We made a chart. And you guys told me yesterday that you could just plug that into L1 and L2, and you could get the mean and standard deviation like we did with discrete random variables, right? By the way, did you guys realize binomial distributions are discrete random variables?
What's a discrete random?
A discrete random variable is a countable variable where I'm counting something and it has probabilities associated with it.
Oh.
Binomial random variables are discrete because what am I counting? I'm counting a number of successes, okay? So a binomial random variable is always discrete, okay? But it additionally has a set number of trials. A discrete random variable, I'm not doing a set number of trials, and it's not necessarily a chance process. It's not necessarily that I am doing something over and over again many, many times, okay? So, but this, I could plug this into L1 and L2 and get the mean and standard deviation. But here's the good news. For a binomial random variable, we actually can get the mean and standard deviation using our parameters of n and p. So, the mean of a binomial random variable, I can just take n and multiply by p. If I take the number of trials and I multiply by the probability of success, that'll give me the average number of successes that I should anticipate when I do my set number of trials. The standard deviation of a binomial random variable is the square root. You should not be shocked. All standard deviations are square rooted numbers, right? It is the square root of n times p times 1 minus p. So, what is that actually? That is our number of trials, our probability of success, times
The failure.
our probability of failure. And I take the square root of that, and I will get the standard deviation. Now, last night, I had an epiphany after 9 years of teaching AP Stats. Huh? This was my epiphany. whether I take that chart that we had and I plug it into L1 and L2, or I use these formulas, I get the same exact mean and standard deviation no matter what. To the millionth decimal place. They are exactly the same mean and standard deviation. So if you have a chart and you feel more comfortable using L1 and L2, go for it. If you don't have a chart and you know it's binomial, how do you know it's binomial? Bins. Then you can do mean and standard deviation like this, all right? Now, this only works for binomial, all right? Here's the good news. These are on your formula sheet, okay? And it's very specific on your formula sheet. It literally says for a binomial random variable, here's the formula, here's the mean, here's the standard deviation. I will try really hard to have a formula sheet for you guys tomorrow so you can look at it.
Thank you.
All right, cool. So there's that. Do you guys have questions on the mean and standard deviation formula on what they are? We'll use them here in a few minutes.
I don't get how like the number of trials times the probability of success, but that doesn't matter.
You'll see in a few minutes. Okay, cool. All right, now for the big one here. Here we go. Now for the big one. This is what you really probably want to know from me. How do you calculate binomial probabilities on the calculator? So I'm going to start with to calculate the probability that X equals a specific number of successes. This is how do you use the calculator to calculate an exact number of successes, okay? So to do this, I'm going to tell you how first, and then we'll do it. You're going to go to second vars. Have you done anything under second vars before?
Distribution.
You've done distributions, right? The normal distribution is here. Hey guys, guess what binomial is? It's a distribution. So everybody go to second vars and go find binomial.
Binomial CDF or PDF?
Ah, there are two options. Here's the deal. For an equal to sign, for an exact distinct number of successes, you are going to use binomial PDF.
Normal PDF.
Don't you dare use normal PDF ever in your life in my class.
You said PDF?
When do you ever use that?
Never.
Wait, you literally just said PDF.
I did for binomial.
Poison.
Binomial PDF. So, everybody go to binomial PDF. Second vars, binomial PDF. It is option A for you guys, right?
Yeah.
Okay, perfect. What is it asking you for?
Trials.
Trials. Guess what that is?
And
That's your N, okay? Then what does it ask?
X for the probability, I guess?
It asks for P, which is your probability of success. Okay, cool. Then what does it ask for?
X value.
X value. What do you guys think the X value is?
What success is?
The number of successes that you're trying to find the probability of. Okay? So, here's what I want you guys to do for me. I would like for you to verify our results from yesterday. So, under trials, you're going to put 4. Under trials, you're going to put 4. Do you guys remember the probability of type O blood from yesterday?
25%.
Nope.
Yeah.
What was it?
It's 25%.
Oh, I'm sorry. 0.25, very good. Then I want you to put in a number of successes of 0. Everybody do 4 for your trials, number of successes,
Oh, it's the same.
or P, and then number of successes.
Oh.
So 4,
Yeah.
comma,
Oh, there's a comma.
0.25, comma,
Is it like this on the
0.
regular calculator?
no.
Oh, okay.
Okay. Hey, you guys, is it the same number from yesterday?
Yes.
All right, just to get in the habit, here's what I want you to do. Go back to second vars. A for binomial PDF. and I want you to do trials 4, probability of success 0.25, number of successes, put in a 1.
Oh.
What do you get?
42.2.
Same thing from yesterday.
42.2.
Guess what? I want you to do it one more time, but I want you to put in a 4. A 4.
Oh my gosh.
I'm killing you.
4.
Put in a 4. What do you get?
Oh, it's the same.
It's the same
0.0039.
thing. Crazy, right?
Oh.
So, here we go. Miss Lakey. Miss Lakey, you mean you made us do all that crap by hand yesterday and we could have just done this? Uh-huh. Why'd you do that, Miss Lakey? Because I love you.
It's like, that doesn't make sense.
I did that so that you understand the parts of the formula. Because you have to be able to recognize what numbers go into where in that formula. You have to understand the formula and how it gets done in your calculator. Now, that's the easy one, you guys. Here's the hard one. To calculate the probability that X is less than or equal to a number of successes. Now, we haven't done this yet in an example. And I'm going to tell you why. It's because to do it by hand, like we did the ones yesterday, it's a little cumbersome. So I'm not going to ever make you guys do this one by hand, but this is why this is difficult. Because look at what it's asked. It says, to calculate the probability that X is what?
Greater,
Less than or equal to a number of successes. That is the only thing that binomial PD or CDF will calculate. It will only calculate a number that is less than or equal to a number of successes. Here's what I mean. What is the probability that less than or equal to 2 of the 4 kids have type O blood? Now, if you have a chart, you know what you could do? You can just add up the probabilities of 2, 1, and 0 and call it a day, just like we did with discrete random variables, okay? We can just add those up, okay? But for our calculator, here's what we do.
This does it automatically?
We would go to second vars and B, which is binomial CDF. By the way, the C stands for cumulative density function. So I am cumulating from the number of successes down to 0. Down to 0, okay? So this is from X down to 0. So this is basically from 0 up to X. That's what we are accumulating, from 0 up to X, whatever the X number is. All right, what does it ask you on your calculator when you go here? It asks you for the same thing. Trials is N, okay? P, that's your probability of success. Same thing, right? Now, here's the deal. X. This is where we have to be extremely careful when we are using binomial CDF. This is what is the highest number of successes that you want to include. What is the highest number of successes that you want to include? Highest number of successes to include. And what is it always going to start from? 0. It's always going to go from 0 up to this highest number of successes to include. Okay? All right, so here's why this is tricky. Here we go. Everybody go to binomial CDF. Binomial CDF. Second vars B for binomial CDF. Put in trials is 4. Put in a probability of success is 0.25. And I want you to go ahead and put in a highest number of success of 0.
Whoa. It's going to give us the same answer.
So you should get just the probability of 0, right? Did you?
Yes.
You should.
Yes, we did.
You should. Okay, y'all should all be with me right now because I'm about to unveil the whole thing. The wizard is about to be shown.
Okay.
Okay.
Know what the wizard knows.
Okay. Everybody did binomial CDF with trials of 4. Probability of success is 0.25. Highest number of successes to include is 0, right? And you got the same thing as 0, right? Okay. Here's why. Because you only went from 0 to 0. That's it. Here's what you're going to do now. Everybody, go back to binomial CDF. And I want you to put in a highest number of successes of 1.
Uh-oh. Wow.
Now, what do you get?
73.8.
What is that number?
The chances of
73 point.
This is, okay, so think about from yesterday. What was the probability of 0?
31.
It was what? 0.3,
1. Yes, it's addition.
0.3, 311?
316.
316? Okay. 4? Okay. What was the probability of 1?
422.
422?
Yep.
Okay. So, hey guys, does anyone see what this number is that you just got on your calculator?
It's those two added together.
It's these two added
Oh my
together. Because you just told your calculator to accumulate from 0 up to a number of successes of 1. I want everybody to go to second VAR's binomial CDF. And I want you to now put in a X value of 2.
Wow.
Is there a faster way to get on it?
It keeps adding up.
Go up.
What was the probability of exactly 2 yesterday?
What?
0.2 something?
Point,
No, it's 9492.
Hang on.
Oh, what are you doing?
What was it, McKenna?
Wait,
Point two,
what am I
one,
supposed to put in too?
0.2109. Okay, cool. So you guys, guess what you just did? You just found the probability of 0 successes plus 1 success plus 2 successes. You just found the probability that you get a number of successes that is less than or equal to 2. You just cumulated these two, okay?
What about greater than?
I'm not there yet. All right. I know what you're thinking. Miss Lakey, I don't want to do this anymore, but yes, you do. I want you to do this for me. Put in a 3. Everybody put in a 3.
I was screaming. I was like,
McKenna, can you tell me what was the probability of exactly 3 yesterday?
1 moment.
Thank you.
Oh my gosh, Miss Lake.
0.0469.
0.0469. Thank you very much. And then yesterday, our probability of 4 was 0.0039.
39, yeah.
Okay. Hey guys, you know what you should have on your calculator if you have put in the if you have done binomial CDF
1 minus
4.25?
0.00.
You are getting 1 minus that, aren't you?
Oh my gosh, yeah.
Okay, one more time. I want you to go back to binomial CDF for the last time for this example, and I want you to put in a 4. What should you get?
1.
You should get 1. You know why? Because you are now including everything. Isn't this cool?
No. That's
All
awesome.
right. Now, do you guys have any questions about binomial CDF?
No, this is awesome.
Okay, now, here's where it's not awesome. It's exactly what Austin just asked me. What if I ask you guys this question? What is the probability that the number of successes is greater than 2? What are you going to do?
Oh, not that.
Here's the
I know.
here's the deal, you guys.
Can't do it.
You have to change the problem to match that.
Yes.
So, if I am asking you for the probability in this situation, we've got 0, 1, 2, 3, and 4. If I'm asking you for the probability that x is greater than 2, what am I asking you for?
3 and 4 combined.
I am asking you for 3 and 4 combined. So, how could I change that problem so that my calculator can handle it?
You could,
remember,
Oh, I know what you could
what
do.
does all of this add up to?
1.
1.
Oh, you could do 1.
1 minus.
Second binomial
Hang on.
CDF.
So yes, you're on the right track. But tell me in notation, what are you finding here? 1 minus the probability of what?
1 minus the probability of 0, 1, and 2.
So that x is less than or equal to
Oh. Less than or equal to 2.
2. Okay? Now, here's the cool thing. You guys, in your calculator, on a blank screen, go to a blank screen. Go to a blank screen. You can type 1 minus, and then go to binomial CDF. Put in your trials of 4, your probability of success of 0.25, and your number of successes 2.
Oh my gosh.
And it will immediately do it for you, okay? And you should now have on your calculator what 3 and 4 were added together.
Wait,
No
say
way.
that again.
That's so awesome.
You go to binomial?
You
Yep.
go to 1
Okay.
minus,
Yeah, I worked
then
on that.
binomial CDF,
Alright,
then you type in all the data,
okay.
so 4 trials, 0.25 probability, and then you do 2 for
Yeah, yeah.
number of successes, because that would be 0, 1, and 2 combined.
The X value too.
Yeah, X values too, because that's 0, 1, and 2 combined.
Thank you.
Okay? All right. You guys, it gets even better.
I don't believe you.
Ready? Watch this. Well, okay. It gets even more fun for you. So, what if I asked you guys this question? Find the probability that x is greater than or equal to 2.
Okay.
What would that be? Again, remembering you have to use x is less than or equal to the number of successes. So, what would you actually be finding using that notation?
It'd be 1 minus the
Okay.
probability that X is less than or equal to 1.
You got it. Do you guys all see this?
Yes.
Are you sure?
Yes.
This is the hardest part of binomial CDF, and this is why I struggle a little bit with using it on the calculator, but there's no other way. So, there's one other option that you might have to transform. The probability that x is less than 2. That is not what you need. What do you need it to say?
What you need it to say is probability of X is less than or equal to 1.
Perfect. Okay, do you see that? So, what's the rule here?
The big picture is
The big picture, the rule.
um,
If you are asked to go greater than, you're going to need a 1 minus. If you have an equal to sign, then you have to do less than less than that number for the greater than. If you have the not equal to sign, but it's already less than, you have to go 1 down. Okay, all that's confusing. Here's what I always do. I'm not even gonna lie. All right, this is what Miss Lakey does when she is doing a binomial CDF problem, just for funsies, because you know that's all I do on the weekends, right? All right, so here's the deal. Let's say I have a set number of trials of 20, right? N equals 20, and let's say I'm looking for a number of successes. So let's say I'm doing the probability that x is less than, 14, okay? I literally always do this. I write out the numbers that are near that number. So like 10, 11, 12, 13, 14, 15. And I go, okay, if x is less than 14, that means I'm doing 13 or lower. And so that gives me a visual of what I'm finding, which is the probability that x is less than or equal to 13. Or maybe, let's say I'm trying to find the probability that x is greater than 12, right? Greater than 12. Then I go, okay, I'm trying to find the probability that x is greater than 12, so that's this. So that would be 1 minus the probability that x is less than or equal to 12. Okay? So, that's how I can wrap my brain around making sure I have the right thing, right? Mm-hmm. So, if you need to do that, just know, nobody's going to look at your paper and go, oh, poor little baby didn't know how to do that. No, everybody's going to look at that paper and go, that's pretty smart. That's pretty dang smart. Let's freaking go. Okay? Honestly, the hardest part of binomial is that right there. The rest of it's not that hard. It's just knowing and remembering that our calculator is confined to doing this particular command, that x is less than or equal to the number of successes. And you have to transform it however you got to do it in order to put it into the calculator. Got it? Whew. It's a tough one. It's a tough one. And you know how you're going to get good at that? Freaking practicing. You know how you don't get good at that? Saying, hey, bro, send me the answer to the sapling, and I don't want to do it by myself. I don't want to punch these buttons on the calculator. I just want to look at your paper and answer it on my paper.
McKenna, you got us?
Is it okay to use binomial PDF and binomial CDF commands on the AP exam?
See,
But we ran out of room like a long time ago.
Only if you define the variables. Guys, this is exactly like with normal CDF, right? You can write normal CDF all day long on your AP exam as long as you label lower, upper, mu, and sigma. So what I'm saying here is, let's say you are trying to find the probability that x equals a number. You are more than welcome to write on your AP exam binomial PDF, because it's an equal to sign, right? Equal to sign gets the PDF. Binomial PDF of n equals blank, p equals blank, and x equals blank. No one... This is how you show your work.
Wait, we have to show work on the AP exam?
Oh, for sure.
Are you kidding?
No, I'm not kidding.
You have to prove.
You have to show what you did. Yeah.
Who, like, checks that?
The AP graders.
Are they, like, strict about
Yes,
that?
we are.
Are you kidding or joking?
Not kidding.
So you're joking.
Yeah, I'm not joking.
You're looking at one of them right now.
You are looking at an AP grader. Hello, my name is Miss Lakey, and I will be grading AP exams this summer. All right. Probability that x is less than or equal to a number of successes. You need to write binomial CDF. N equals blank, P equals blank, X equals blank. As long as you write that, you're golden for showing your work. You have shown your work. How we doing? We got it? Everybody feel good? We got calculator inputs. We love doing calculator inputs, don't we? All right, here we go. Let's do an example.
Oh, I think you told me about that, actually. Oh, you would.
In roulette, 18 of the 38 spaces on the wheel are black. Suppose you observe the next 10 spins of the roulette wheel. First of all, is this binomial? What do I check? Bins.
I forgot.
Is there success and failure?
Yeah. No.
What is success?
They should have outlined.
No, because there's four. There's three different.
What is failure?
Oh, you're right. Black is success. Failure is any other space.
Cool. All right, independent. Is each spin on a roulette wheel independent?
Absolutely.
Okay, so spins are independent. Perfect. N. What does N stand for in bins?
Trials.
Number of trials. Do I have a set number of trials? 10. P. What is, I'm sorry, not P. S. Bins. What does S stand for?
Probability.
Probability of success. So success probability is fixed. Do I have a fixed probability of getting black?
We can calculate it.
What is it?
It's 18 divided by 38.
18 over 38. You got it. Very good.
Oh, you don't want it.
Sure, you can tell me the decimal. I'll take it.
0.4737.
Okay, perfect. I'll take that. You know, you can use 18 over 38 as well. That's cool. All right. Y'all ready? Find the probability that exactly 4 of the spins land on black. I am finding the probability that x equals 4. I'm finding the probability that x equals 4. So, I know that I have shown you your fancy little calculator trick. So what are you going to do on your calculator now?
We're going to go to the math.
No, you don't have to go to math. You can go to binom, which one? Is this a PDF or a CDF?
This is a PDF.
This is a PDF because I got an equal to sign. Binomial PDF. What does n equal?
Number of trials.
Number of trials. N is 10. What does P equal?
Probability of success.
Probability of success. Hey guys, by the way, you can put 18 over 38 in your calculator.
Oh,
That's
do
fine.
that then.
All right, what is X? What is the number of successes we're wanting?
4.
4. Very good. You plug that in, you hit enter, and boom, you have an answer. If you tell me the answer, it is
0.2247.
0.2247. Now, ladies and gentlemen, this, what I have written on the board, would get you full credit on the AP exam because I have defined my variables and I have my answer and I said what I was doing, okay? But I'm going to go ahead and write the formula with the numbers plugged in because you might need to recognize it on a multiple choice test, okay? So here's what it would look like in formula notation. It would be 10, choose 4, right? 10, choose 4. Probability of success is 18 out of 38. How many successes?
How many successes? Well,
4. Probability of failure would be 1 minus 18 over 38. And how many failures? 6. That is what it would look like in my formula. Could I find how many 10 choose 4 is?
yeah.
I could, using the 10 NCR4, I could find out how many different options that is. I totally could. And then I could just plug the rest of that in my calculator, right? I could do that. Again, you would only have to do this in a multiple choice setting. This is enough work to get credit on a free response, okay? Got it?
Got it.
You'll see some questions like this on Sapling that are multiple choice that'll say, what is the binomial formula? And it'll show you the inputs and you have to pick the right one. All right, kids, we will continue this tomorrow. Boy, that was fun, wasn't it?